Hello, my name is Mike Mead. I'm the Manager of Safety at Cass County Electric. Today, we're going to talk about electrical safety and high voltage electricity. With me, I have Lightning Liz and Neon Leon in my tabletop demo. When I'm done talking, one of our apprentice line workers, Billy Nelson, he will talk about electrical safety working on high voltage power lines. His job day in and day out is working with high voltage, and he does it safely because he's been trained to do that, and he also has the proper safety gear to work on those power lines. So when we're all done with this program, we want to remind you, we don't want you to play around power lines, only trained professionals. Electricity is generated in many ways. We use coal, use natural gas, nuclear, water to drive turbines, wind and solar, all ways electricity is made. So once that electricity is made, we have to get it from that point to your house. That's what the electric co-op does. We get the electricity from one point to the next so you can use it. Electricity is generated, we put it into a transformer. That transformer bumps that voltage from one level to another. We do that up and down as needed. We need higher voltages to go longer distances. So for about every 1,000 volts, we can push it about a mile. So our big power plant is out in central North Dakota, about 230, 240 miles from here. And the transmission lines that carry it are about a 230 kV line or 230,000 volt line. So that's how we get electricity all the way across the state to Fargo. And then from there, it's broke up and we move it around the country, and that's going to be on either 115,000 kV lines or 69 kV lines. And at that point, we take it over in the substation, which has a transformer in it, and we bump it down to 13,800 volts in Fargo, and in the rural areas, it's 7,200 volts phase to ground. So that's a lot of information, but that's what we're going to talk about today. So now we've got electricity all the way to our houses, and we want to talk a little bit about safety around electricity. Working on the power lines, a line worker is one who does that. They're trained and qualified. They go through 9 months of school. Some schooling is a little bit less, but in general about 9 months of school. Then they come into a 4-year apprenticeship program. My apprentice with today, we'll talk more about it, but during those 4 years, they work with journeyman line workers, and they teach them how to work on electricity safely. So the reason I'm here today is to let you know that electricity is very safe, very easy to use, but can be very deadly. So we don't want you to play with electricity. We want you to allow the people who are trained to do it work on electricity. Hopefully by the end of the presentation, you'll understand all that. A couple things we need to keep in mind are going to be insulators and conductors. So an insulator stops the flow of electricity. My rubber gloves have insulation, and these gloves are actually tested each month, and I know that it'll take more than 26,000 volts electricity to break this glove down, so I will not get hurt if I'm wearing these gloves. Each day before use, they get tested and inspected to make sure they're going to protect us like they're supposed to. So that's going to insulator. Porcelain, fiberglass, wood can also be an insulator. A conductor is anything that allows electricity to flow easily. The metal wires, that's how we get electricity from A to B, is we have the metal wires to tell electricity where to go, and we have the insulators to stop it so it doesn't go where we want it to go. Pretty simple, right? All right. So now we've made electricity. We're moving it through the countryside to your homes. We have the lines out there. You'll see the overhead lines are easy to see. The underground lines you can't always see. You'll see the green boxes out there. We'll talk a little bit about those. We've got the transformers out there that take that 7,200 volts or 13,800 volts and drop it down to 120 to 240 volts for your household use. Everyone that I'm talking to right now uses electricity. We have our lights, can be heat, can cook our food. All those ways we use electricity, computers, TVs. It's a very important part of our life, and we want it, and it's very safe when it's done properly. Like I said, we use insulators and conductors to get electricity to do what we want. Electricity it only cares about getting back to earth ground. It's always looking for that path to ground. We don't want to be that path. So as long as we're not the path for electricity to go to ground, we can be safe. So electricity will take each and every path it can find to ground. More electricity flows through the least resistance to ground, and that's where the metal wires come in play. Okay, so now as we look at our tabletop demo, we can see we have power because those light bulbs are on. But if those light bulbs were burned out, would we still have power flowing? And the answer is you can't tell by looking if a power line has power in it or not. So if a power line ever breaks and falls to the ground, we do not want you to go up and touch it or get anywhere near it. Stay at least a couple hundred feet away from it. Make sure you notify somebody to get a hold of the utility, whether it's your parents or an adult, and they can call us, and then the line worker will come out and make the scene safe. So right now our power lines are up in the air. We have lights on, so we know we have power. But if those lights were to burn out, or if that wire falls on the ground, we can't tell by looking at the wire if there's power there. Now if we see arcs and sparks, then we know there's power there. But it could lay in the ground and still be energized. And if we touch it, now we've just made a good path to ground and we can get hurt. So electricity is traveling through this top wire. There's 77,200 volts electricity in this wire. And as long as I just touch the one wire, I don't have a path to ground because I have my rubber gloves on and I'm protected. Now if I touch an energized wire and a grounded wire, which our neutral is, now I get the arc. So this is what we don't want. We don't want uncontrolled electricity to go into ground. Or if we're a person and we touch it, like Lightning Liz here, that's electricity flowing through her body or through the neon lights lighting up. So hopefully everyone understands that we don't want to be the path to ground right now. With that, we're going to talk about some different ways for electricity to go to ground. And we're going to start with a kite. I'm guessing everyone here likes to fly a kite. And as long as we're flying a kite, we don't want to be near power lines. Stay as far away as possible. If for some reason you're not paying attention and your kite gets too close to the power lines, what you're going to want to do is just drop it and let it fly away. Because if we don't do that and that kite gets caught in the power lines, that kite string can actually conduct electricity. So you can see the electricity is flowing down the kite string and going through Lightning Liz to ground. Or also, if it gets caught in the power lines, as you can see, there's a little bit of spark there. So that kite string was conducting just about as good as that piece of metal I had. Now, I cheated a little bit because this is actually a wet kite string. Very important to remember, water is a very good conductor of electricity. And with that, we're going to talk a little bit about a piece of wood being a conductor or an insulator. So I asked the class, and you can answer to yourself, is a piece of wood an insulator or a conductor? The answer is it can be both. A dry piece of wood, which this is a dry piece of wood, is an insulator. 40 years ago, the sticks that the linemen used to work on power lines were made out of wood. The problem being is when they get dirty and wet and contaminated, they're tough to clean, and now they can conduct electricity like this wet piece of wood. So as you can see, there's electricity going through the wood, and hopefully you can see that it's actually burning a little bit there. I'll make a little smoke. Now I have to be careful if I make too much smoke. I set up the fire alarm, so I can't do a good demo on that. But I can tell you right now, I can definitely smell it, and the wood is burning. So a wet piece of wood will conduct electricity. All living trees, just like all living human beings, have water in them and will conduct electricity. So that's why if you've ever seen where we come out and have to cut trees back near the power lines, it may not look very pretty, but we have to do that for your safety. Because if that tree is touching the power line, somewhere along that tree, it's going to be energized. If you come and touch that energized piece of wood and your feet are on earth ground or you have a path to ground, you can have electricity flow through your body. You can get shocked and or electrocuted. So that's why we cut the trees back, and it doesn't look very pretty, but we need to do that for your safety. So next, I'm going to have a squirrel help me out here. And you've probably seen birds or squirrels up on power lines. Hopefully everyone knows now, if the squirrel is on the power line, they're okay and they're safe. I'm going to ask the class, you can just answer to yourself, how can that be? How can they be on that energized power wire and not get hurt? And I know you all answered they didn't have a path to ground. Because now if they touch something grounded and that energized wire, now electricity is going to flow and they're going to get shocked and or electrocuted. All right. And it's the same thing. Metal, as I mentioned before, is a great conductor of electricity. Anything that's metal, we don't want to use around power lines. So even if you go home and you see your parents work around power lines and they're using a metal ladder, let them know that that's not safe. Maybe they forgot. Maybe they never got to see a presentation like this. But metal conducts electricity, and if it comes into contact with that energized power wire, they can get hurt. So we've talked a little bit about the overhead power lines. Very useful, very much needed, but as long as the wires are up in the air, we're okay. What happens if a car loses control, hits the power line, and the wire falls on the car? Now we have what could be a very dangerous situation. That car could be energized. So we need to make sure that if at all possible, we stay in the car. That's the safest thing to do. Call for help. Use your cell phone. Call for help. They'll get a hold of the utility if you call 911. And we actually have a direct number from 911 to our control center so we can get people as quick as possible to come help you. Stay in the car. We'll come out, de-energize the power, and let you out. If you have to get out of the car because of it starts on fire, you have to be very careful. You do not want to touch that metal car and earth ground at the same time. So stand on the door well, and then you want to jump. Keep your feet together, which you probably can't see right now, but my feet are together, and you're going to want to either shuffle or hop all the way until you get about 50, 60 feet away from that car, because what happens is you have what we call step potential. That car is energized. The ground around it is energized at different levels. That energy is dissipating or decreasing. And as it does that, if you have a spot that has 6,000 volts of electricity and another spot that has 5,000 volts of electricity, and your feet are separated, that 1,000 volts can go through your body. So that's what you want to be careful. If you want to keep your feet together so they're at the same potential as that energized surface you're on. And don't touch the car at the same time you're touching the ground. Now hopefully that tells us how to be safe if the chance that wire ever falls on it, on a car. Now if we're out after maybe a storm, or maybe we saw a car and we want to go help, don't run up to that car because it could be energized. If there's wires laying on the ground from either storms or vehicle damages or whatever, do not run up to that power line to see if it's energized or de-energized. Call the utility. Utility will come out. They'll check it out. They'll put on their protective gear, and they'll make the scene safe. So, as you can see, Neon Leon here is lighting up a little bit. So he decided to go out and dig a hole without calling North Dakota 1 call or Minnesota 1 call, which is Gopher State. If you take and do that and you hit a power line, now it's just the same as the overhead line. The electricity is going to flow through you looking back for that path to ground. So now if you notice a little bit, Neon Leon, he lit up a little bit, but not a whole lot, because what you can't see is I have a little piece of plastic down here, and he's actually got a little bit of insulation. It's not great, but it's a little bit of insulation. Now if Liz comes up to help him, she's not got any insulation or no protection at all. And now we're going to see what happens when we have less resistance to ground. You see how more electricity is flowing through both of them equally now? So that's what we need to be very careful of, that if someone is getting shocked, we don't run up and try to help them, because we could actually cause more damage by doing that. All right. One other thing I want to talk about is the path to ground. Electricity, we used to always say electricity takes the easiest path to ground, which is correct, but it actually takes all paths to ground. So what I'm going to do is touch both Neon Leon, Lightning Liz in the same spot. If you can see, a lot of electricity is flowing through Lightning Liz, and just a little bit is flowing through Neon Leon. You can barely see it, but he is lighting up a little bit. Again, he's on some insulation, so he's got a little bit of protection. Not enough to protect him, but some. So more electricity is going to go through the easier path to ground. But if you look closely, electricity is taking all paths to ground. Okay, I'm going to leave you with one more reminder. Please don't play along the green electrical boxes that are in your yard. And with that, I'm done, and I want to thank you, and I'm going to turn this over to Billy Nelson, our apprentice line worker.
Hi guys, I'm Billy Nelson. I'm an apprentice lineman here at Cass County Electric in Fargo. I went to school to be an electrical lineman, 10 months in college, and then now I'm continuing on my 4-year apprenticeship program. But in college, I learned how to climb, set poles, frame poles, terminate underground. Here at Cass County, I am continuing my 4-year apprenticeship program through bookwork and on-the-job hours. We need 8,000 hours to become a journeyman. I'm right around 6,000, so 8,000 hours ends up being about 4 years, 2,000 a year. Now we're doing hot work here, and I'm going to show you some of the tools and PPE equipment that we use on a day-to-day basis. Here's some safety equipment, personal protective equipment. Each lineman is assigned all of this. and tools that we use on the job. First up, we have my rubber sleeves. This protects your upper arms and your forearm, whether you're climbing in a bucket truck or working on underground power lines. Comes up here and wraps around your shoulder and goes to your wrist. This is specialized rubber. We check it every day before we use it. You can't just go to the store and buy this. It's special ordered. Here we have our high voltage rubber gloves. Again, special rubber. We test it every single day. They're personally assigned, so everybody has their own pair here at work. And then we have our secondary voltage gloves. These are low voltage for working on meter bases, the secondaries in our transformers, and street lights. And then we have cut-proof leather gloves here. It helps keep your hands protected, whether you're stripping cable, cutting cardboard boxes open, just simple things. And we also, even the clothes we wear, have to wear special clothing. These are FR clothes, which is fire retardant. That means if there was to be an accident, they won't keep burning. We wear steel-toed boots so we don't hurt our feet on the job, and we have electric-rated hard hats so that our hard hats even don't conduct electricity. We're required to wear safety glasses also, of course. And we have our climbing gear here. This is my belt. It's a lot thicker than the belt you use to hold up your pants. This has to carry all your body weight and strap you to the pole. And these are the gaffs that you put your foot here and then you strap it around your leg. These gaffs have big sharp spikes in them that dig into the wood of the pole, and you can climb up it just like a ladder. This is a piece of our underground primary wire. On the very inside, we have the conductor. This is where the 7200 volts is at. Right here is the insulation, which shields the conductor from the other parts of the wire. This wire is almost a 2-in-1 wire. In a normal house, you would have a phase and a neutral. In our mainline wire, we have both into one conductor. So we have the hot, we have some insulation, and this black part here we call semicon. It's just another layer between the insulation and our neutral. This is copper here. This is our neutral wire for this phase. And then our outside protectant jacket, which keeps water and dirt off of all the good parts. And you'd think it wouldn't be as dangerous as overhead, but I feel it's quite a bit more because you can't see it under the dirt. We'll go to our shotgun here. We call it a shotgun because you can pump it just like a firearm. Mike was talking about our old sticks used to be made out of wood, and dirt would be embedded into the grain, and it would hold moisture and make it conductive. All of our new sticks are fiberglass. They're much easier to wipe off. You can test them. They're a lot more safe also. They're rated for insulating for a lot higher voltage. This is one that I would say we use the most for close quarters. The hook up top, you're able to turn clamps such as this up in the air. See how this has to spin to open up and close? You can put it in the hook and then rotate the whole tool. And it helps keep us away from the energized lines. You never want to go and touch it, even with your special gloves. You want to try and stay away from it. Just in case a arc was ever to happen, the further you are away, the less danger you're in. Imagine it as getting close to a campfire. You stand 10 feet back, you can't feel the flame. If you're right next to it, it's very hot. So this is our shotgun. We also have fiberglass extendo sticks, we call them. They telescope out and lock together for reaching up higher to higher wires. We also use them to beat ice off the lines during winter storms. The ice will build up onto the wire, and it will take a wire from going from being this big to about that. And then it also makes the wire very heavy, so it hangs down, which is dangerous to both people and animals. If the wires sag, they can get close to the ground. So we need to go and beat the wire off. Squirrels also like to travel our lines. If you notice, you'll see squirrels and birds walking up on our wire. And Mike was talking about equal potential. When they just touch one wire, it's perfectly fine. It doesn't hurt the squirrel, it doesn't hurt our wire. But as soon as they get onto our transformers in everybody's yard, the can that knocks our lines down from 7200 to 120, 240 for your houses, they end up blowing a fuse. It stinks, but it's a quick fix. We can get your house turned back on and keep you guys happy. Mike went into if wires were laying on the ground. You aren't able to see electricity. It's safe if you treat it properly and you have the right personal protective equipment. But if there's a storm and you have wires laying on the ground or a tree falls, don't go try and touch them. Don't grab a wooden stick and say, oh, I saw this on a safety video. Just talk to your parents and call us and we'll get it fixed. We have the right equipment, we have the knowledge to work on it, and we just want everybody to be safe. Same goes for underground wires. If there's construction work going on in the neighborhood and there's a big pit and you see wires in the hole, don't go try and touch them. They're exposed so people know where they're at and they don't hit them. But they're just as dangerous as overhead lines. They might be a little bit bigger around, but that doesn't mean they're safe.